Okay, so I think this reaction we already discussed. Zinc plus H2SO4. What does it give? Anyone remembers?
ZnSO4.
Yes.
ZnSO4 plus H2.
H2. Very good. That's good. And you people had asked me to explain the reaction with HCl also. So reaction with of zinc with HCl will be something like this.
Sir, why will it be Cl2?
That's a very good question. Why ZnCl2? Why not ZnCl? I will explain that in a bit. Before that, tell me if this equation is already balanced or not. Is it balanced equation or is it a skeletal?
Sir, doesn't look like it.
Okay, so get confirmation. See, check the how can we confirm that it's balanced or not balanced?
Sir, it looks like it's imbalanced one because for hydrogen on left side it is single and on right side it is double.
Yes.
And for Cl also same, sir.
If we put 2 before HCl, then it will become balanced.
Yes, that's good. If we put a 2 here, it will become balanced. But let's start from the beginning. How many atoms of zinc are there already? 1. Hydrogen also 1. Chlorine also 1. Everything is 1, 1 here. What about this side? Zinc is 1. Hydrogen is 2 and chlorine is also 2. Now, how can we make this 2, 2? Zinc is already fine. Hydrogen and chlorine we can make 2 by just multiplying a 2 over here. Now it is completely balanced. All of them are 2, 2 and 1.
Sir?
Yes, tell me.
Sir, but on right hand side, why do we have to write Cl2 and
Yes,
H2?
I'm coming to that. Okay, H2 should be clear to you. I explained, no? Hydrogen cannot exist just as H, no?
Yes, sir.
Yeah, it makes a bond with another hydrogen and becomes H2. Okay, now let's talk about why ZnCl2. Okay, to understand that, ZnCl2 is a molecule, and how are molecules formed? By some bonding, right? Zinc and chlorine, they have to form some kind of bond between them. Okay. So as of now, I asked you people to remember all the valencies up to 30, atomic number up to 30. From now on, I'll send you a document which will have all the atomic numbers also up to 30. Okay, so I'll share it today or tomorrow, and you can start remembering that. So for now, I'll tell you what is the valency of zinc. The valency of zinc is 2. Everybody knows what valency means, right? We had talked about it. Valency means the capacity to combine with other elements. How many electrons it can give or take. That is the, yeah. For zinc, that is 2. And what about chlorine? What is the valency of chlorine?
1.
Yes. The valency of chlorine is 1. Chlorine has an electronic configuration of 2, 7. So it can accept 1 electron. So if I do a bonding, see, the zinc can give you 2 electrons, but this chlorine can take only 1. So where will the other electron go? So one of the electron of zinc will be shared with 1 chlorine and the other has to be shared with other chlorine. That is why when they bond together, they make ZnCl2 and not just ZnCl. Because ZnCl will not be stable. This zinc can give away 2 electrons. This guy can take only 1. So if you want to take 2, there has to be 2 atoms of chlorine. Does it make sense?
Yes, sir.
Okay, fine. So what did I delete it? Let it be. Yeah, fine. So we're okay with this. Activity 1.3, we have seen both the reactions, zinc with hydrochloric acid and zinc with sulfuric acid. Both reactions we have seen. And I will send you more notes about these activities. You can go through that in more detail. And you will understand a few more things about these once we have gone through all the different types of chemical equations. Okay, so for now, let's leave it to that. And we are going to continue balancing chemical equations. So we had done balancing for this one. Up to here, we had completed, right? Zinc plus H2SO4, ZnSO4 plus H2. And we saw that this was already balanced. There was nothing to balance here. Zinc was 1 here, hydrogen 2, sulfur 1, oxygen 4. Same thing on the RHS also. So there was nothing to balance. This equation is already balanced. Okay. Now let's go ahead. Let's try to balance this equation. You people give a try. Check whether it's already balanced or not.
Sir, it is skeletal equation.
No, sir, it is not balanced.
So it is not balanced. Okay, that's good. Let's try to balance it. To balance, what do you do? Let's go through this stepwise, okay? How they're asking us to do NCRT stepwise. First of all, let's write the equation. So we are going to continue with this. Tell me, one of you, do you have the book with you? What is the equation? Fe?
Sir,
Fe
it's
plus
H2O gives what?
Fe3,
Fe3.
Zero four O
O4.
four plus H2.
Okay, this is Fe3O4. Okay, 3 atoms of iron and 4 atoms of oxygen. Fe3O4. This is called ferric oxide.
Sir, which one?
This one,
Sir, what did you call it?
ferric oxide. Iron can make when iron combines with oxygen. Actually, it can make two compounds, two kinds of oxides. Okay, so before going into iron, which is a little complicated, let me give you an example of carbon itself. You know that carbon, when combines with oxygen, it can make two kinds of oxides. Anyone knows what kind of oxides carbon makes?
carbon dioxide and carbon monoxide.
Very good, very good. That's good. Carbon monoxide and carbon dioxide. So both kinds of bonds are possible. Same way for iron also. Iron, when combines with oxygen, it can make two kinds of oxides. One is Fe2O3 and then Fe3O4. This one is ferrous oxide. This is ferric oxide. Or maybe sometimes I forget the name. Let me confirm. Sometimes I mix up the name. Just let me check that. Oh yeah, I was right. I was mixing it up. Okay. I do this like I always, when I was studying chemistry, earlier, I used to have this confusion, which I'm still carrying with me, the ferrous and ferric confusion. Okay. So actually this one with Fe2O3, this is ferric oxide. And the one with Fe3O4, this is ferrous oxide.
What is the name of the second one, sir?
Just I'm writing. Hold on 1 second. Okay, so I'm not sure about the spelling. Ferr, ferrous oxide. Okay, so these are the two kinds of oxides it makes. Okay, so don't go too deep. Just keep this in mind. Okay, there's nothing to worry about this. You don't have to know too many things. All these things very clearly. It's not part of your 10th syllabus as of now. But just remember, Fe3O4 is one of the oxides of iron. Okay. Okay. So yeah, this was your ferrous oxide. Yeah, is it balanced? It's not balanced. We will do the balancing now. Let's check how many atoms are there on the left-hand side for each. What are the molecules? Here I can see iron, then hydrogen, and then oxygen. So iron, hydrogen, oxygen, iron, hydrogen, oxygen. Everybody knows Fe is a symbol for iron, right? That everybody knows?
Yes, sir.
Okay, how many atoms of iron on the left-hand side?
One, sir.
Only one. Hydrogen, how many?
Two, sir.
Oxygen?
One, sir.
One, sir.
The right side?
3, sir.
Iron 3.
Four. Two hydrogen, sir. Four oxygen.
4, sir.
Okay. Fine. Now, we have just written all the atoms. How many atoms are there on the left-hand side and right-hand side? Let's do this through the NCERT book also. Let's say what they are saying. What should be our first step when we want to do the balancing? So who will read?
To balance a chemical equation, first drawn box around each formula. Do not change anything inside the boxes while balancing the equation.
To balance a chemical equation, first draw the box around each formula. Do not change anything inside the box. Okay, see, why are they asking you to put that box? It has to do with the same question which Pragati asked me, or who asked me? There was MGO and you asked me that, can I write 2 in between over here? You asked, no?
Sir, it was me.
Pragati, okay. So that is why they are asking you to put it inside a box, because this is a molecule. You cannot change the structure of molecule. If it is MgO, the magnesium oxide is defined as MgO, then you cannot change that, write it as Mg2O or MgO3. That's not possible. Like we saw an example, no? Zinc has a valency of 2, chlorine has a valency of 1. So when they make a molecule together, it has to be written as ZnCl2. So this is the zinc chloride molecule. You can't change the ZnCl2. That's why they ask you to put this inside a box. And if you want to do anything, you can multiply a 2 outside, or a 3 outside, or a 4 outside. Outside you can multiply with any number, but don't change anything in the structure of the molecule. That is why they are asking you to put everything in a box. Don't change the structure of the molecule. So is this first point clear to everyone? Why are they asking us to put it in a box?
Yes, sir.
All right. Go ahead, Tanushri, second step.
Yes, sir. List the number of the atoms of different elements present in the unbalanced equation. Table 1.5, sir.
That's okay. We have already done this step. We have already written all the number of atoms on the reactant side also, and number of atom in the product side also. This is what they are asking you to do as the second step. List the number of atoms of different elements present in the unbalanced equation. Number of atom in the reactant, number of atom in the product. Okay, we are already done with this step. Move on to the third one. I think everyone is clear how to do this, no? Second step, everyone knows how to do. Let's move on to the third one. Go ahead, Tanushri, read this third one.
It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In
Okay,
that
stop,
compound,
stop,
select the
stop, stop. Yeah, this is a very important point. If you have the book with you, underline it or highlight it, whatever you do. So when you are doing balancing of equations and you have a situation like this, like iron is 1, hydrogen 2, oxygen 1, this side 4, 2, 3, so many different numbers are there. So which one should I start balancing? Everything is unbalanced, right? Except for hydrogen. Iron is also unbalanced, oxygen is also unbalanced. So where should I start balancing? For that, you have the answer here. We should start balancing with the number which is the highest number of atoms, the compound which has the highest number of atoms. And remember, it can be either in a product or a reactant, anywhere, whichever is the highest. So which one is the highest over here? Where should we start?
Oxygen.
Yes, it's very simple. It is oxygen here. This is the highest one. So we should start balancing with oxygen. So if this is 4 here, what will I have to do? I have to multiply this with 4, right? Now, where is my oxygen? It's here. And as you know, I can't do anything inside. So I'll have to multiply a 4 over here, correct? Multiply
Yes,
of,
sir.
yes, sir.
so multiply a 4. So when you multiply a 4, this becomes, now this has become 4. But because we put 4 here, now hydrogen has also changed. How many atoms hydrogen has become now? It has become
6, sir.
4 2s are 8.
8, sir.
Yes, be careful. Okay, 4 2s are 8. So since we had to multiply 4, hydrogen also changed. Now, so oxygen is balanced now. We are happy, no problem. Let's see what the next step says over here. So as you can see, let's not go through too many wordings over here. They'll confuse you. But just understand this is what they did. They tried to balance the oxygen and they multiplied water molecule with a 4. So 4 molecules of water we have taken just like us. And when that happened, the structure changed again. So how many atoms of hydrogen? Initially there were only 2, but now it is 8. So in the reactants it is 8. In the products it is 2. Correct. Now, which one should I take up? Again, hydrogen is the highest now. It is 8 over here. So let's try to balance the hydrogen. What should I do? How can I balance my hydrogen?
So multiply 4 on right side, sir.
Yes, I'll have to multiply this hydrogen with a 4. And luckily this hydrogen is alone. So when I multiply 4, this is just going to be 8 and it is balanced. It did not disturb anything else. So with this step, our oxygen is also done and hydrogen is also done. Now look at iron. What happens with iron? On the RHS, it is
So
3.
multiplied by 3.
Multiply by 3 on the left hand side over here. So this becomes 3. Okay. So everything is balanced now. Now this is our balanced chemical equation. So maybe if you want, you can go through the recording again and try to see how we did this and it will be more clear to you, okay? Anyone has any question, by the way? Is it clear?
Yes, sir.
Yeah, we have to try to balance it stepwise, okay? Yeah, so we can skip these steps. We have already completed them. Finally, to check the correctness, we count the number of atoms. So once you have done, you'll of course count it, and we did the counting. Everything was fine. 3 atoms of iron on the left, 3 on the right. 8 atoms of hydrogen on the left, 8 on the right. 4 of oxygen on the left, 4 on the right. Everything is balanced. Okay, so after that, this is balanced, very fine. We have written a balanced chemical equation. What is that balanced chemical
Sir?
equation? Yes.
Sir, if iron is uh, like mixed with H2SO4, then
You will learn that when metals react with acid, what happens? This we will learn in metals and non-metals chapter also, and acids and bases chapter also. You will see that. That is something to do with the next chapter, or it might appear in this chapter also. We'll see if that equation comes up in some example somewhere. Okay, metal reacts with acid, it gives a salt and hydrogen gas again, just like when zinc reacted with H2SO4, it gave you ZnSO4 and hydrogen. It will react in a similar manner, but the valency and all those things, I don't want to go into the detail right now, because iron can take 2 valencies. Okay, 2 or 3, both.
Sir, can you give some equations, sir? We'll do it.
Yes, I will. Sanushri, is that you?
Yes, sir. Here in this device,
Okay. Yeah, so before I give you questions, let me talk to you about this step over here. Okay, we were reading it stepwise, so we have done up to this 6th step. We have balanced the chemical equation, but even after that, there is still something very important which we need to do as a last step: writing the symbols of the physical state. So whatever your reactants or products are, they have certain kind of state, whether they are solid, liquid, or gas. Those things, liquid means we call it as aqueous, AQ. Solid means it will be solid, of course. And if it is a gas, we just represent it with a G. So the
sir,
state,
for iron it will be S, for hydrogen it will be G, and for oxygen also it will be G.
yeah, but this is your H2O, this is water, so this is aqueous, okay?
The aqueous.
And when something is solid, like Fe3O4, this could be, let's see, well, what kind of state it is in. As you can see here, iron was solid, and this H2O, normally it is liquid, but it is in gaseous form. So they are taking a steam. They are making this iron react with the steam. You will learn why. Because when you just take, if you just take an iron rod and you dip this in water, do you think it will start reacting? Have you ever seen water?
After a period of time, sir.
No, it reacts very slowly, and it needs certain condition. It has to be wet, and it has some part of it has to be open. Some oxygen also has to be there around it. If you fully dip it inside the water, it will not rust. Okay, you learn that rusting and corrosion, we will talk about that. So if you just take this iron and if you put it in liquid water, it will not react so easily. That is why they have taken steam, okay? Because steam is very hot and it reacts with iron more quickly, and it gives you this ferrous oxide, which is a solid, which is what basically your yeah, and then your gas. So these states are also important: solid, gas, whatever it is. Solid and gas is very easy, S and G for that. For liquid, you don't write L. That's not correct, okay? You write normally aqueous solution or something. Okay, so aqueous is also there and liquid is also there. You can write liquid also.
Sir, what is this 340 ATM?
You can go to an ATM and take out 340 rupees.
So there is no ATM nearby, sir.
This is online ATM. Okay, so in reality, this ATM means atmospheric pressure. Okay, 340 atmospheric pressure. Which is a high.
Sir, sorry to join in this account, sir, because in that device there is a low power, sir. That's why.
That's all right, no problem.
Sir, today I will pay the fees, sir.
That's okay, Tanushri. Okay, let's focus on chemistry right now.
Sir, I'll too do that, sir.
Yeah, that's okay. So do you people understand? You have to write the states also. That is also an important step of completing the chemical reaction. Once you have written the states, then the chemical reaction becomes totally complete. So we have completed up to this. In the next class, we will discuss these questions, and I will also give you more questions on balancing. Okay, I'll give you more questions and you will be doing the balancing. We'll do that in the next class.
Okay, sir.
Yeah, it's almost at the end of the class right now, so I don't want you to people to hold up. So we'll do that. I'll give you more examples.
Thank you, sir.
Okay, then. See you all.
Thank you, sir.
We'll see you. Yes. Anyone has any question? Tell me.
Yes, sir. In page number 5, there is
Thank
the
you, sir.
equation of 1.12. So that equation is it the like photosynthesis process, sir?
Yes, exactly. You're talking.
So for carbon dioxide, they have given aqueous, like it takes in carbon dioxide gas in your plants.
Yes, it takes carbon dioxide gas, but what happens? It gets mixed up with water, the vapor. Okay, inside the leaves, it gets combined with the liquid, and in that form, it takes reacts with the water. Okay, to give all these things.
Okay.
Okay. Anyone else has any questions? Okay, fine then. I'll see you all tomorrow. Bye-bye.
Thank you, sir.